Lecture 3? 2?
2. We count from 0 going.
Count from 0. Start 0 based. Lecture 2.
Okay, so welcome back everybody. Today we are going to finish covering the basics of Objective-C. Can you guys hear me in the back okay? Back? Anybody can hear? Anybody? No? Can you not hear me?
No.
Apparently you can't hear me. Is this loud enough in the back? Okay. All right, thanks. Okay, so this is kind of a hodgepodge of just a little, slightly more advanced basics, if that makes any sense. Just slightly some more sophisticated basic topics of Objective-C that we didn't get to cover last time. So just as a review, like I said, people really tend to struggle with the message syntax of Objective-C, so it's worth going over again just to really make sure that you are familiar with how you define a method in Objective-C, how you call a method in Objective-C, and what those look like. So here's a basic no-parameter method call. Again, we have the minus sign to indicate that this is an instance method rather than a class method. In parentheses, we have the return type, we have the name of the message, and then in curly braces, the body of the method, whatever that happens to be. When we want to call that method, we start with a square bracket, saying I'm going to call a method. The first thing is the object to which you want to send the message, and then the text of the message, followed by a closing square bracket. Everybody cool with this methods call? It's the no parameter case is usually pretty straightforward. It's just the text of the message that you want to send. Cool? Okay, and here is the an example one parameter method call in Objective-C. So again, we have the minus sign to indicate this is an instance method, the return type, again in parentheses, then the name of the message followed by a colon to indicate that the next thing that's going to go in here is a parameter, and then when we declare the method, we say the type of the parameter, and then a variable name, or a name for the variable that's going to be that parameter, and then again, in curly braces, the body. When we call that method, we are going to start with a square bracket again. We're going to say the object we want to send the message to, then the message name, in this case, rows and sections, colon, and then insert a parameter there at that position, and close the square bracket. Does that make sense to everybody? Remember seeing something like that in the lab last time, I hope? Okay, and then lastly, the two-parameter case, or multi-parameter case. Again, we have the minus sign to indicate instance method, the return type in parentheses, and then the first part of the message name, colon, then the parameter, then the rest of the message name, then the colon, then the last parameter. And then when you call that, we have the square bracket, the object you want to send the message to, message part 1 of the message, parameter, part 2 of the message, parameter. Any questions about the message syntax? It's really important that you guys understand that. So if there's something that's not clear about it, let us know soon. Because from this point on, I assume that you know how to do that. Okay, so the first topic that we're going to talk about today is the topic of a selector. So the idea of a selector is it's essentially an object, and that's in quotes because it's not an object in the Objective-C sense of the object. It's just kind of a thing that identifies the name of a method. In particular, it's not a function implementation, so it's not a reference to the section of code that fulfills that method. In particular, it's not a function pointer like we're used to if you've used C. It's just an object that identifies a method with a particular name. Its type is a new type called SEL, or cell. And selectors are really quite important for being able to do dynamic binding and polymorphism. And sometimes when people talk about Objective-C methods, they'll call them selectors. The reason they're called selectors is because they select a method to call on the object that you're sending the message to. And essentially the way they work is they basically just match a method whose string is the same as the string of the selector. There's a bit of implementation detail that makes it more efficient, but so you can create selectors using the compiler directive @selector paren. Within the parenthesis, you put the literal text of the selector. So here, in this bottom example, we're selecting a method set with height. Under the hood, a selector is basically an integer value. It's essentially, I think it's essentially a hash of the selector string. That's basically for efficiency reasons. Abstractly, the way to think about a selector is it's just a string that's the name of the message, and it identifies which method on the object you want to call. So you can think about it as literally passing the string across to the other object. Obviously, it doesn't actually do that because passing it along a lot of strings is kind of inefficient, so it actually compiles it down to an integer value. But effectively, we're just identifying a method on an object by the string of the message name. One kind of unusual thing that some people might find about selectors is that this same selector here, set width colon height colon, will actually identify any one of these methods, despite the fact that they're different. Because the selector doesn't encode the type, the return type. It doesn't encode parameter types or parameter names, just the message name part of the method. So I guess if you had a class with multiple of these, it's not defined which one gets called. I don't know. Although whether or not you're actually allowed to do that at all is maybe not happening. Can you even do that? Have multiple methods that are the same signature but different types?
I don't think so.
I'm going to say no, so you shouldn't have to worry about that. But the idea is a selector doesn't care about those things. It just knows that it's got this text as the message name, and that's it. So that's the efficient way to create a compiler, is using the @selector directive. That's done at compile time, so you only have to compute that value once. If you need a bit more dynamism and you need to create a selector on the fly, you can actually do that by just using the C function NSSelector from string. It takes in an NS string that's the name of the selector you want to select, and it creates a selector for a method with that name. One thing to note about selectors is that they're not bound to an object of a particular type. They really are just a method whose text is this, or whatever the text is. It's not bound to an object at all. It's just literally the text of the method. So you can pass around a selector to any object you want, and it may or may not listen to it. And we'll see how to do that. Conversely, if you have a selector and you want to write out its string representation, there's a function NSString from selector if you need to do that, usually for debugging purposes. Okay, so that's all fine. What is that even good for? You're probably wondering. So here's kind of an unusual way to use selectors. This is a very contrived example. But suppose we have a selector for a method named quack, and then we have some Donald Duck object, and we say perform selector quack selector. So that's basically telling the object, I'm sending you a selector, which is going to select a method from one of that object's list of methods, and it's going to invoke that method, whatever that selector happens to match. So these two statements are actually equivalent to directly calling quack on Donald Duck, which is kind of a roundabout way to do it. But what's cool about this is that it allows you can dynamically generate the selector or the object at runtime. You can also pass in objects using perform selector. There's another flavor of the method called perform selector with object that takes in a selector and then an object to pass in. So notice that this selector has a colon. It's worth noting that the colons in the parenthesis of the selector are very important. Fetch without a colon is a no parameter method. Fetch with a colon is a one parameter method. And so those will select different methods. But here we're saying to Fido perform selector, fetch selector with this object, some ball. I guess it's a dog. And so that is effectively the same as messaging Fido with fetch and passing in as a parameter the ball. I believe there's also perform selector with object and another object or something. I don't think there's any more beyond that. I don't know why. Usually you don't need more than two. Okay, so that's kind of a fairly esoteric example of what you can use selectors for. Like I mentioned before, they're really quite useful for enabling polymorphism and really very dynamic method dispatch. This is an example from Apple where we have some function that generates an object, and we have some other function that generates a selector. And at compile time, we don't know what object we're going to send the message to, let alone what message we're going to send. But yeah, we can do it. So this is really useful if you need a lot of dynamism and you can swap out object underneath and have objects these methods get called very, very dynamically. The main usage that you'll see most likely of selectors is something called the target action pattern. We'll talk about this in more detail later when we start to getting into actually implementing user interfaces. But just to kind of get you thinking about it, so we have a graphical user interface to an application, and there are some control objects in it, like switches or buttons or sliders or those kind of things. And the question is, when the user interacts with one of those objects, we want to call some piece of our code. And how do we want to go about that? How do we want to link interaction with a user interface element to a section of code that you've written? And Apple has done this in, I think, a very extremely clean way, and it's called the target action pattern because there are two parts of it. Basically, the idea is the control when something interesting happens to it, when you tap a button, when you slide a slider, when you flip a switch, it sends a message. So that's a selector. And so the action you specify is a selector, and it's just the method you want to call when some event happens to the control. As far as the control object is concerned, it doesn't really care what the object that you're sending the message to is. As long as it responds to that message, it can call it. So you just specify a selector, and then you specify an object that you want to send the message to. What's nice about this is, since this is very dynamic, if you want to change the implementation of your function or your method, or change the object that you're using, it's really easy because you just change the object and then you kind of just relink the selector and the action, or a target in the action. But again, we'll see this later in more detail when we actually start implementing UIs. This is just kind of the most common use case of selectors, is to select methods when something happens to a user interface element. So here's an example here. Suppose we have some button, and we want to call the method button clicked every time the button gets clicked. We can say, assuming we've defined this method button clicked in this class, we can say send the message to self, and the message to send is the selector button clicked. One neat thing about this, again, we'll talk about this later, but if a selector for an action takes in a parameter, the parameter that gets passed in is the object that sent the action. So that way you can, if you have a bunch of buttons that all call the same method when the buttons get pressed, you can tell which button sent the message in the first place. So that way you don't have to write a button method for every button in your code. You can just write them all in one place and then switch off of the button. One other benefit of using, for example, perform selector is that it allows you to do safe messaging. So the compiler will automatically generate a warning if you attempt to call a method that an object might not respond to. Note that in Objective-C that's a warning, not an error, because it's possible that that object will respond to that method. It can't determine that until runtime because all method dispatch is done at runtime. So it can't issue an error, it can only issue a warning saying, hey, this object might not listen to this method, but try it if you want. One thing to watch out for is, so if you want to suppress that warning, one kind of sneaky way around it is to just say perform selector with that selector. The compiler can't determine if the perform selector will work, because again, that's done at runtime. One thing to be careful though is if you do invoke perform selector with a selector that the object doesn't respond to, you'll crash. And there's a way to test if an object will respond to a selector, and that enables something called duck typing. Who's heard the expression, if it walks like a duck and quacks like a duck, it's probably a duck? So this is a programming idea called duck typing, and the idea is if a duck can quack, it's probably a duck. You don't really care. What's neat about it is if this object responds to the selector quack selector, meaning the response to the selector basically says, if I were to send this message to the object, would it be able to give me an answer? And if that's yes, then I can tell it to quack, regardless of what object actually is. Does that make sense? Okay, so any questions about selectors in general? I know that's kind of abstract. Hopefully you'll get an example of a selector in today's lab, so hopefully that'll help. All right, so the next thing that we're going to talk about is something called properties. And first I'm going to motivate what properties are. So again, let's go back to our fraction class. So our header is probably going to look something like this. We have a numerator and denominator, and we have two methods to set it, and they look something like this. The set numerator is kind of boring. The set denominator, we might want to check if it's not 0, so that way we don't divide by 0. And then we also have methods for getting back the numerator and denominator out of the object. And if you've done any object-oriented programming, you've probably found that you write methods like this a lot. Like a lot. If you want to properly encapsulate your variables, you make them private and then write setters and getters for them. This is basically writing that. So shouldn't there be a better way to do this? Like it's most of this code is so simple that you shouldn't have to write it. The compiler should be able to be smart enough to write methods for you. And as of Objective-C 2, there is a way to do that. Objective-C 2 added this feature called properties that allows the compiler to automatically generate setters and getters for you, so that you don't have to write them. So here's that same class again, but I'm gonna write those setters and getters using properties instead. So again, notice how much shorter this is. We have a numerator and denominator, and I'm just going to say that those are properties. So I say declare at property, the type of the property, and then the name of the property. And then in the implementation file, we just say synthesize. And the synthesize directive is a way of telling that's actually what tells the compiler, write this for me. The property syntax here in the interface basically says I'm going to define. You could effectively replace this with the two method declarations that would come out of this. So int numerator and void set numerator int numerator. The property line just basically says this class provides two methods called set numerator and numerator for getting the two values. Does that make sense? And then the synthesize line just says compiler, write those methods for me. There's also another keyword at dynamic that's not often used, but at dynamic says there isn't one in this source file, but there will be one by the time it runs. Because one of the really neat things about the Objective-C runtime is that it allows you to actually add, remove, and modify methods on the fly, which is kind of frightening, but it's actually one of the really powerful things about the runtime is that you can modify the code in your object at runtime. One problem with this, though, is I kind of gave it away there. But one problem is that the default synthesize will just set the property, will set the value blindly, and in the case of the denominator, we don't want it to be 0. So we can actually provide our own implementation for the method if we want. So in this case, the synthesize will basically, since we've provided a method set denominator, the synthesize won't write one for us because it sees that there's one already defined. But it will write the getter for us. In fact, if you wanted, you could not use the synthesize at all and provide both method implementations if you need custom behavior on them. Does that make sense? Okay, so if you can provide the bodies anyway, what else is there? Must be something else neat about properties. And the really neat thing, especially if you're like a Java person and you're used to accessing members of your objects using the dot syntax, properties also brought the dot syntax to Objective-C. So if a variable on a class is declared as a property, only as a property, then you can access it and set it using the dot syntax. So for example, if we've declared numerator as a property and we want to get the numerator of an object, normally we would just say a fraction numerator, calling the actual method on the numerator, on the fraction. Or we can use the property syntax to say a fraction dot numerator, and that will return. This effectively expands into that method call. Similarly, if rather than just getting the value, you actually assign to it, that will effectively expand into the setter call. Like methods, properties can be nested. So if this is a person object, I suppose, and it has a property that's a dog object, and that dog object has a property that's a tail, you could just say owner dog tail, or you could say owner dot dog dot tail to chain your way down to those objects. Does that make sense? It's worth noting that you can, if you really wanted to, you could force the runtime to use methods this way. Don't do that. Nobody knows what you're talking about. The dot syntax is reserved exclusively for properties and nothing else. Even if you have another instance variable that's not a property, you can't access it using the dot syntax. It's exclusively for properties. And the reason for that is that when the compiler effectively compiles it as a method call, not actually as the access. Okay, so there are some more things we can do to properties to make them more useful. We can do a lot of powerful customization of the setters and getters that the compiler writes for us, so that we don't have to do write everything. If we want something a little bit custom, we don't have to write a custom one. We can just tell the compiler, I want it like normal, but with this one other thing. And so we can decorate property declarations with some various attributes so that we can get customized accessors. And I'll go over the different parts you can do. The first thing you can do that's pretty easy is you can change the names of the methods that get generated. So by default, the getter is just the name of the property. If you want to change what the name of the getter method is, then you can say getter equals the name of the getter you want, and it can be some other custom method name. So that when you call the method, you'll just use that method name rather than the default property name. Similarly, you can change the setter, which has a default value of set property name is the name of the setter by default. If you want to change the setter, you can say setter equals the name of some setter, and that will be the new method name of the setter. You can also modify the writability of the property. So by default, properties are both read and write, so that means you can set it and get it. If you want to have no setter, then you can mark it as being read only, so that way you can get a getter but no setter. So there's a little bit of semantics that you can add to the setter. A little bit of this we're not going to talk about until we know about memory management, which we'll talk about the next couple lectures. But so there's three ways that the setter can work. The first is that the setter just does a simple assignment on the value. Basically, if you say object.property equals some new value, then in the implementation for that function, it will say instance variable equals new value, and that's basically the entire body. So that's very much like the body that we saw back here. Oh boy, that's fine. Okay, so that's this is the set numerator implementation. That's just an assigned setter. Just as a simple regular C assignment. The next semantic that you can set is something called retain. And I'm going to basically skip this until we know about memory management. But basically, it does assignment, and then it invokes this method retain on the object. And we'll talk about what that means in 2 lectures. And then lastly, you can set the last property is the copy property. So it can, rather than assigning the object that actually gets assigned, it can take a copy of the object and then assign that instead. Note that copy only makes sense on Objective-C objects. Any primitive types like ints and floats are already copied anyway, because there's but copy only makes sense on objects because it will actually invoke the copy method. And again, we'll talk about that more when we talk about memory management. And then the last thing that we can do with properties is, well, there might be more, but these are the important ones, is changing what's called the atomicity of it. By default, all the accessors, both the setters and the getters, are what's called atomic, which means that only one thread can be writing or reading at any given time. So there's a bit of overhead on the part of the compiler to make sure that they're actually atomic. So that includes writing things like locks to make sure that only one thread can access that property at a time. So there's a minor inefficiency there. If you know that your code is going to be a single-threaded and you want to make it as fast as possible, you can flag them as being non-atomic, which means that the compiler will not write all those locks and semaphores to lock down access to the variable, which if you're single-threaded is no big deal. If you're multi-threaded, that's very dangerous. Okay, so I have some examples here of different ways to set properties. So again, here's our fraction class, and the way you decorate property declarations with attributes is after the @property line, or after the @property keyword, inside of parentheses, you just put a comma-separated list of all the different attributes that you want to set. So suppose we have some single-threaded application that deals with fractions. Since we're single-threaded, we can make both of these non-atomic because we don't need to worry about thread safety. And since they're just primitive types, we're just going to say assign on them. Calling retain or copy on ints doesn't make any sense because they're not objects. Assign is, I believe, the default value anyway, but just to make, sometimes it's useful to make it clear that you want it to be assigned, just to make it clear. So here's another example. Suppose we have a checkers game and we need to store the board of that checkers game. It might make sense to be able to retain that object. And again, that deals with memory management, but it basically makes sure that the object doesn't get memory managed, doesn't get deallocated too early. And then one sort of weird thing about properties since Snow Leopard, I believe, is that it used to be that if you had a property, you had to have an instance variable of the same name and type within the class. As of, I think it's Snow Leopard, you don't need to have that instance variable to match anymore. If it finds that there's a property that does not have an instance variable, it will generate one for you. Generally speaking, it's a better idea to, and if for no other reason than to make it more clear to you that you should actually declare it as an instance variable. Sometimes people want to have the instance variable be named differently than the property, and you can actually do that with the @synthesize line. There's an optional part where you can say if you have variable name. Suppose we had the instance variable was called _name, but we wanted this property to use that instance variable for storage. On the @synthesize line, we could say @synthesize name equals _name to indicate that's the variable to use for storage. That's kind of that's sort of the convention using underscores to indicate private variables. Again, it's just a convention though. So the main one really common use case for changing the setter and getters is with if the property is a Boolean value. The Objective-C convention is that if a property is a Boolean value, the getter should be named is some adjective, and the setter should be something like set that adjective. So depending on what name you give your variable, you may have to change the name of the setter and getter to actually accomplish that. So that's pretty much the only time that I've ever used getter equals and setter equals, just to kind of stick with convention of making the Boolean getter be is adjective. Any questions about properties? Again, I think you'll see these in the lab today. Okay, so the next topic is the idea of a protocol. And a protocol, if you're familiar with Java, it's the exact same idea as an interface. Basically, it's just a list of methods that you can include in any class, and it's shared among all the classes. And the key part is that these methods don't have implementations. They just have declarations of methods. And so a class can implement a protocol by including the header for that protocol and then providing bodies for those methods inside of that class. So the formal syntax of a protocol is to say @protocol, the name of the protocol, and then in a bunch of method declarations and @end. Very simple. If you want to be a bit more fancy, there are two other keywords you can add. There's @optional and @required that will indicate whether or not those methods are required for that protocol. And the way these work is at the @optional line, everything below it is optional until you get to an @required, in which case everything below that is required until you get to an @optional, and so on. Does that make sense? Yeah. By default, they're required, unless you mark them with optional. Good question. Okay, so here's an example protocol. Suppose we're writing some drawing application, and we want a protocol for every object that we can possibly draw. And rather than define some superclass of all objects that we can draw, we're just going to define, or declare rather, some methods that all objects that can be drawn need to fulfill. So, for example, they can be painted, they can be erased, and if optionally they can have an outline. And then when we define a class that we want to be able to draw, we include the protocol and provide bodies for these methods. That way, any object that uses that class knows that it provides bodies for these methods. So the first thing we do is we import the header for the protocol, and then to indicate that your class will conform to the protocol, after the superclass inside of angle brackets, you provide the name of the protocol that you plan to implement. And then in the implementation file for that class, you provide bodies for those methods. Note that you don't need to put declarations for those methods in the interface section of the class, because those method declarations already exist in the protocol declaration. So that's why there are definitions of those methods in the implementation file, but no corresponding declarations in the interface file.
Does that mean the protocol has no implementation file, it's just a header file?
Yeah, exactly. Protocol files are just they don't have to be in a file. Like all of these things, really, they don't have to be in separate files. The convention is that they are, and if you define a separate file for a protocol, the convention is to put it in a header file. Okay, so you can create a protocol object using the @protocol directive. This, unlike selectors, is an actual object that you can message. Mainly, protocol objects are useful to test other objects for conformance to a protocol, and to see if they fulfill all the methods of that protocol. So here is a protocol, and again, inside of the parentheses of protocol, you just put the literal text of the protocol name. It doesn't need to be a string or anything. It's just the actual characters of the name of the protocol, and the compiler will generate a protocol object for you. That's useful for the method conforms to protocol, which is a method defined on NSObject that takes in a protocol object and returns yes or no, depending on whether or not that object conforms to the protocol. And if it does, then that means that you know that you can call any of the methods from that protocol on that object. So again, what's nice about this is that we don't really know, or care for that matter, what object is. As long as it can be drawn, as long as it fulfills the drawing protocol, then we know we can paint it. Does that make sense? And conforms to protocol will, no, actually, never mind. Okay, so classes can also implement multiple protocols if you want, and all you do the only difference is in the header file, you just comma separate the names of the protocols inside of the angle brackets, and then provide bodies for all of those in the implementation file. The compiler will automatically generate a warning for you if your class declares that it's going to conform to a protocol, but doesn't provide bodies for all of the required methods. If you don't provide bodies for optional methods, it won't generate a warning for you. But if you are missing a required method, then it will tell you that you're missing one, so that way you know to provide one. So object type declarations can be extended to include support for formal protocols. So this first declaration is any object that conforms to the protocol my protocol. And so that means that now you know, since the type of the object is some object that conforms to my protocol, then that means that you know that you can call any method from that protocol on that object, regardless of what it is, as long as it's typed correctly. Static types can also be extended to have a protocol declaration. So that's why we have, for example, some object type, my protocol, an object. And so that's an object that's of class my object that also conforms to that protocol. Does that make sense? Okay, so the next topic are what are called categories. Question. The point of a formal protocol is just how do I explain how? I mean, they come up a lot where some class it's not. Want to explain this plan? Why do you use protocols and interfaces, like in Java?
We have to for multiple type inheritance, right? I mean, that's how they get around multiple inheritance in Java. And then it's mostly like an API abstraction decision that you're basically creating a contract for the users of your API to say this is what I'm explicitly supporting, and this is what you need to explicitly have in any subclasses. So it's like an API frameworks, a way to engineer clean API frameworks, and to make sure that subclasses and subclasses and subclasses all follow a standard that you've set.
And it's an alternative to subclassing when you don't have data associated with it, but just method calls.
Yeah, I mean, sort of the basic idea is you write some code and you expect some other person to write code that uses yours, and you can't provide the logic for some methods that they have to provide it custom for each different class that uses your API. And so you just define, okay, as long as you have some object that fulfills these methods, then I can use it in my API.
Daniel actually made I'm going to reiterate, he made a really good point about, you'll see a lot of the classes in the documentation use protocols instead of fully subclassing another large class. Like if you don't want to subclass NS window and have to supply a whole bunch of custom methods and overrides, you can add protocols to it instead, and that way you kind of tack things on the side in a clean way without having to completely subclass the whole parent class.
Yes, and we have a lecture on that very topic about a broader concept called delegation that we'll cover in some number of weeks. Okay, so one more topic are something called categories. The most common use of a category is what's called is using for class extension, so that way you can add behavior to a class that's already existing. This is often useful if one of the classes that Alpha provides, you just really want some extra behavior out of this one class, but it doesn't make a lot of sense to subclass or like try to redefine the class or whatever. So you can actually add methods to the class using a category. Before Objective-C actually had protocol support, everybody did protocols with something called informal protocols, and we'll talk about that in a second. And those were done using categories. So the way you define a category is the convention is the name of the file is the name of the class you're extending plus sign the name of the category, and you have to first import the class that you're providing the category for, and then you just say an interface for the class name, in parentheses the name of the category. Since this isn't a subclass, you don't need to provide the parent class or whatever. It's just you're extending a class and adding more behavior to a class. So you just kind of have to give your category some unique name to kind of identify which category your methods belong to. And then the implementation file, you provide bodies for those. So like I said, before there were real protocols in Objective-C, everybody did what were called informal protocols, which were categories on NS object, which is strongly not recommended as the way to do this anymore. Mostly because protocols have formal language support, so that in particular, like I mentioned, you'll get compiler warnings if you don't fulfill all the methods. If you don't fulfill all the methods in an informal protocol, you can't get compiler warnings. Another problem with informal protocols is that if multiple informal protocols define the same method, it's undefined which one is which. So there's a collision issue with categories that there is not with protocols because they belong to different protocols. But categories, they all belong to NS object, so it's unclear which one is which. But if you want to do it, you can. Don't though. Okay, so one last really short topic, and it's short because you don't use them very often in Objective-C, are about exceptions. So Objective-C has exception support. You can throw exceptions using the @throw directive, and then the next statement is usually an exception object. It's basically an Objective-C object. Usually it's an NS exception, and then you handle exceptions using at try, at catch, and at finally for handling those exceptions. And you can catch multiple different kinds of exceptions using multiple different catch blocks. Objective-C exceptions are, so here's an example of using a try-catch for different exception types. Objective-C exceptions are rather inefficient, which is one of the reasons the language doesn't use them very much at all. I honestly can say I've never written a try-catch block in Objective-C. I've just never needed it. The dynamism of the language kind of eliminates the need for it. So, yeah, like I said, I've never used an exception in Objective-C, so you really, it's rather amazing that you don't need exceptions. The language just really takes care of itself. But if you really need them, you can do it. Yeah.
What's the point of the at finally?
So the at finally block will get called regardless of whether or not you catch an exception.
It's a good place to clean up or finish it.
So the main reason you have it is, suppose you allocate memory in the try, you want to free it, and you want to free it regardless of whether or not you had an exception.
Close file.
Close files, that kind of thing. Yeah, good. Okay, so that's all I have. I know that was kind of hodgepodgey, but that's basically the language now that you have. There's a bit more about memory management that we'll talk about the next 2 lectures, but that's the basics of the language. And there's another lab today that's, I think, really fun. So go ahead and get started.